Good morning, everyone. In last session, we have completed three type of reactions. So, one more left with us, that is a rearrangement reaction. In today's class, we will finish up that rearrangement reaction, and today we will start the new thing, that is the structure of organic compounds. That means how to write the different structure of organic compounds. So before start this session, one question has someone asked that she has not understood a substitution reaction. Okay, questions are always welcome for me, and this is a subject of chemistry where you will get number of doubts. So don't worry, don't be in a hurry. Definitely we will clear all the doubts. You don't worry about that. But try to watch these videos repeatedly, so that you can come to know why. Because it is very difficult to give the solution for each and every questions. I mean, each and every particular person. So that's why you might be having some doubt. So doubts are always welcome for me, right? No problem. I'm very happy that again. That means what I can say is you people are following my videos. That is the very happiest moment for me. So substitution reaction means, see here, substitute one atom or a ion or a molecule by other. So in the last class we had saw this example, CH2Cl upon reaction with potassium hydroxide. I have already explained you. You just replacement takes place over here. So you replace Cl with the respective ion or a atom or a molecule, right? So definitely, see, I will go in depth. You try to understand. Now here, this chlorine, consider this carbon atom. This carbon atom is very important. Why? Because to this carbon atom, chlorine is attached. Why I am talking about chlorine means chlorine is more electronegative atom. More electronegative is nothing but what? It will drag, right? It will drag these electrons. That means the bonded pair electrons, the electron which are involved in the formation of bond, because of its more electronegativity, it will drag those electrons towards itself. So thus what happens here, the density of electron, right? The density of electron increases on chlorine, right? Like this. The density of electron increases on the chlorine. So that's why now the weight or the mass of chlorine is very high. If I tell you generally, then there must be a mass. If it exceeds, then what happens? Definitely the bond will break down. As such, this bond will break from this carbon of this chlorine in such a way that these two electrons will move with chlorine. That means here, who is the loser? Definitely this carbon. So that means onto this carbon, what charge we should expect? Positive charge. Why? Because this carbon atom has undergone into the loss. Whenever there is a loss, what I said, cation, that means positive charge will be formed. See, if you people not clear with the last videos, then this chemistry is like that only, right? So that's why you have to see each and every video clearly, right? So now the positive charge was formed. Now, with respect to this compound, what is its intention? To get negative only. Why? Because already the positive charge has formed on this. Now potassium is right. Potassium is a metal, so therefore always it carries positive charge, and hydroxyl group is always carries a negative charge. So thus now this positive never will come and attack over here. Why? Because already on this carbonate, I mean in this compound there is a positive charge. Positive positive repel each other. Of course, we all know that. So that means from here, what happens? OH will be attracted. So now the product will be CH3CH2. Now in place of chlorine, what has replaced? What we have to replace? OH. Now K is as it is, and from here, from here, what we have released? Cl. So you just add Cl over here. Definitely the compound will be right. What we have done here, that is very important, right? First of all, the compound is like this actually, but what we did now, we have replaced, we have substituted one atom with the other atom, right? See, in place now you just try to compare these two compounds, that means this one and this one. Over here with this CH2, there was a Cl at the reactant. When it undergone the reaction with the potassium hydroxide, now in place of OH, what we have added, I mean what we have substituted? OH. That means the substitution or replace, I mean one atom or molecule will be displaced from other, or replaced from, or substituted with the other atom. Such reactions are called as substitution reaction. Again, I clear you, here there is no loss or there is no gain. We are just shuffling, you can say simply, right? So this is about the substitution reaction. So addition, substitution as well as elimination we have completed in the last class. So the last reaction is a rearrangement reaction. Rearrangement reaction. So rearrangement means within the same molecule we have to rearrange the atom or molecular ions. So we will take one example like CH2 double bond C 1 2 3 4 H O and H, right, like this. See, rearrangement reactions are very important in the organic chemistry. So addition, substitution, elimination we can understand very easily, but these type of reactions are little bit typical to understand. So that's why I have attention over here. Now here there is a compound with a double bond. I mean there is a double bond, right? So whenever you see the double bond in the organic compound, you just imagine there must be a one pi bond and one will be the sigma bond. And we know about sigma and pi bond. Sigma bonds are very very strong bond and pi bonds are weak bonds, right? Why? Because they form by sidewise overlapping. So that's why the pi bonds are, again what we can say is, these are the partial bonds. They are not actually the bonds, right? These are the partial bonds, not completely we can say bond, or not completely when we can say these are not a bonds, right? They are intermediate we can say, right? So now see, again the electronegativity plays a very important role. So consider or look at this carbon. To this carbon there is an oxygen, and oxygen is more electronegative. And now if I consider, or if we assume the upper bond is a pi bond, then definitely these bond that means these two electrons are always revolving freely, right? So due to the freeness of these pi bonded electron, definitely what happens, this oxygen will attract these electron towards itself. It is more complicated, but try to understand. When we come into, when we come to the offline classes, then we will go again with this rearrangement type of reactions. So for now extent, you just try to just have a glance over here. That means what is rearrangement? So now within the same molecule, we are rearranging the compound. Now, see here, the oxygen, see, before this bond, this pi electron coming near to the oxygen, what was the condition of oxygen? 1 bond, 2 bond, and the valency of oxygen is 2. Now already satisfied, but what is happening? One extra bond is coming in between carbon and oxygen. That means, see, I will just show you later. I will rub this. So now, how many bonds are present around the oxygen? You see this oxygen. That means 1, 2, 3. It cannot tolerate these many bonds. So that's why what happens? This when we move this pi electron or pi bond towards the oxygen, then this oxygen releases the hydrogen. Very important. So now compare the reactant with the product. See, now CH2 as it is, but one H is coming from what? Oxygen. So now the number of hydrogens becomes, we can directly write CH3 or you can show like this, right? So now this part. Now double bond is converted into single bond. Very important. Why? Because double bond went over here. Now C as it is, single bond O. That means C single bond O was there in the reactant. But now in product, because of this bond, the single bond is converted into double bond. H is already gone. We have wrote it over here, and now H, we didn't made any arrangement to the H. H is as it is, right? This type of reaction, that means the rearrangement of the molecule or compound present, the atom or ion present in the molecule within the same molecule. If we rearrange the atoms or ions, then those type of reactions are called as rearrangement reaction. Again, so this is I know that this part is very hard, tough. So again I will explain. See, we have to, first of all, we have to go with the pi bond, right? Once if you know what is pi bond and all, then definitely it will be easier for you people. So in actual, this compound was like this before. See what happens, because of this oxygen only the rearrangement takes place. Why? Because see, in this whole compound, the oxygen only the one atom which is more electronegative. Because of its more electronegativity, these electron, that means pi bonded electron, listen carefully, pi bonded electrons are free. That means the pi bond, the pi bond is partial bond. It is not a complete bond. That means those electrons involved in the formation of pi bond, they are free. Because of their freeness, what happens? Oxygen is more electronegative, and more electronegative atom, what they will do? They will drag those electrons towards themselves. So this oxygen will also do the same. It will drag all these two electrons towards itself. So now between C and O there was a single bond, and now that single bond is converted into double bond, and the oxygen valency is only 2. So that's why it has to remove this hydrogen. This is the rule, I can say. Why? Because after getting its complete valency, there is no need of extra valency. So that's why it will pull this hydrogen, that means the small hydrogen, towards this carbon. So now CH2 becomes CH3. That means before there was a 2 hydrogen with this carbon, Now, after one hydrogen from this oxygen, the number of hydrogen becomes 3. And now there was a single bond in between carbon and carbon. Now the single bond is converted into double. So such reactions are called as rearrangement reactions. So dear students, you go through once again, right? You totally don't depend on the videos. You go and read once. So then, if you are Kannada medium, you these concepts in Kannada and try to convert them. I mean in English. So you can be you can very easily catch these points. Otherwise, it will be bit typical in the video classes. Later, when you come to the offline classes, then we will go repeat these concepts. So this is all about types of reactions. In today's class, we will see structure of organic compounds. This is also very important. So that means a single organic compound we can write in 3 different structures. So that is the structure of organic compounds. So organic compounds are, we can represent these organic compounds in 3 structural forms. Now, first one is complete structure. Second one is condensed structure, and third one is line structure. Right? So these are the 3 these are the 3 type of structure by which one we can write the different forms of these organic compounds. So complete means what, condensed means what, line structure means what, we will see one by one in this video. We will try to complete minimum 2 structures in this video. So let us see a complete structure. These are very easy, you can catch these points very easily. Complete structure means in a molecule, in between 2 atoms, right? In a molecule, in between 2 atoms, we represent the structure by using a dash. Very important and very simple, right? So what we are doing in the complete type of structure, in a molecule, consider one molecule, we will I will show with the example. In a organic compound, between 2 atoms, right? I will write one example. C, H, 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 C, H, H, and H. What is the name? Of course, directly I can say now ethane, because there are 2 carbon atoms. The prefix is eth, and in between carbon and carbon there is a single bond. So that's thus A and E we have to use. So that means ethane. What I said in the complete structure. What is complete structure? What it explains about? So to write the complete structure, what we have to use? We have to use a dash in between any 2 atoms present in a molecule or a compound. Right? What I did, in between, you consider any 2 atoms, carbon and hydrogen. This carbon and this hydrogen you consider. In between carbon and hydrogen, what is there? There is a dash. If you for each and every atom present in the molecule, if you try to use the dash, then such structures are called as complete structures. Right? Very important and very simple, right? So if we use a dash in between any 2 atoms present in the molecule, I mean, there may be a 10 molecule atom in a molecule, there may be a 15 atoms in a molecule. In between each and every atom, there should be a what? Dash. Then such type of structures are called as complete structures. Right? This is the one way. This is one way to represent the or to write the structure of organic compounds. That is complete structure. In complete structure, what we have to do? We have to use the dash in between two atoms, right? So this is about a complete structure. So what about condensed? Condensed structure is just opposite of complete. Condensed structure, right? In condensed structure, what we need to do is we should not use a dash, right? Such structures are called as a condensed structure. So we will see with the example. CH3, CH2, CH2, CH3. So in complete structure, what we did is we used a dash. Those are called as, when we use a dash, then those type of structures are called as complete structures. But when we don't use a dash or without dash structure is called as condensed structure. There should not be a dash between any atoms, right? So such structures are called as a condensed structures, right? In condensed structure, we suppose not to use a dash, right? So with a dash, complete, it will be complete. Without dash, it will be condensed type of structure. You can see many examples, right? So in book, you can come across many examples. Just go through the books like this, right? Having number of carbon atoms, this. But there should not be a dash in between any atoms present in a molecule. If it is a dash, complete structure. Without dash, it is called a condensed structure, right? So last one is there is no need to explain more about these structures. Why? Because they have just a single sentence definitions. So finally, the number 3 is line structure. So this is very important, and these type you can see in your questions in your exam, right? So simply like this. Line structure. In line structure, we should not use CH like alphabets. We have to represent complete structure with line. Then how to identify where there is a C, where there is a H, right? This is the difficulty. Now I can show you the same. If we write the organic compound completely with the line, then such structures are called as line structure. See, what is our compound like this? There is a compound. Now, here, that means here, you just take or consider these are the C. So, in this particular compound, we come across a 3 points or 3 regions, right? 1, 2, 3. So wherever there is a point, what I did, I wrote carbons. So now go with the valency of carbon. With respect to this carbon, how many bonds are present over this carbon? Only 1. So that means still how many we require to complete its valency? Again 3. And for those 3, we will take the help of what? Hydrogen, right? So now coming to this carbon atom, around this carbon atom there are 2 bonds, see 1 and 2, right? So now what is the valency? 4. So that means how many how many require bonds? 2 bonds, and we represent those 2 bonds in the form of hydrogen. And here also the same condition, over this carbon atom there is only single bond, so thus it requires still 3 more. So we will give these 3 in the form of hydrogen. So this is how we can understand with the valency, right? So that means always the starting and the ending carbon is having CH3. In between, see, in last example what I did, like this I did, right? So the terminal carbons, that means end carbons, are always having three hydrogens, but in between carbons like this. In between carbons are always having CH2. Like this, one we can identify these carbon atoms. I mean these compounds, or else you can go solving like this. These are very. This method is very simple. So one more we will see. So here, first you try to identify the points. Number 1, 2, 3 and 4. Right? So 4 means what I said, terminal carbons. That means the last carbons. This carbon and this carbon might be having CH3. Now, this will be always like this. That means CH2. Why? Because around this carbon atom already there are two bonds here, 1 and 2. So that means how many hydrogen we require still? 2. So that's why I wrote CH2. Coming to third carbon atom, the condition is same. If you consider this bond as 1 and this as 2, then it's again required 2 hydrogens. And finally, coming to this last hydrogen carbon, the terminal carbon is having only single bond. So that's why we have to provide a three hydrogen atoms to complete its valency, right? So this is all about the simplest structure types. That means with the help of these simplest type, one we can identify or one we can represent differently. I mean different organic compounds. This is all about today's class. In the tomorrow class, we will go with some more other concepts. Thank you.